Hey everybody, how's it going? It's Todd and I'm back again with you guys on another tech tip video. I have not done any tech tip videos for a while, and I've decided I wanted to share what I've learned on VLANs and inter VLAN routing. For those of you who don't know, a VLAN is used in a switching environment. They're used to separate broadcast domains, so if you want all of your end user workstations on a separate broadcast domain than your servers, which is a fairly common practice, that's where this application would come into play. However, by default, devices on different VLANs are not able to communicate with each other, at least not without the implementation of inter-VLAN routing. VLAN routing can be implemented in a Layer 3 switching environment using switch virtual interfaces, or in a Layer 2 switching environment with the help of a router using 802.1q encapsulation. In this example, I'm going to be setting up inter-VLAN routing using a Layer 3 switch. So without any further ado, let's go ahead and get this started. So I got our multi-layer switch here in the middle. In Packet Tracer, make sure you use the one that says it's a multi-layer switch. These 2960s are just simple Layer 2 switches. So then the next thing we need to do is go ahead and get our end devices placed in here. We'll go ahead and, just for simplicity's sake, just put in a whole whopping 4. Then go ahead and connect them just using the automatic connection type here. Alright, and just to make it a little bit more applicable to real life, we'll go ahead and just name the end devices. So we'll just go ahead and go with Sales 1, Sales 2, Customer Service 1, and Customer Service 2. So what I'm going to do is I'm going to put the sales guys on one VLAN, and I'm going to put the customer service guys on their own VLAN. And before we get started with actually creating the VLANs, let's go ahead and do some documentation. So we're going to say sales VLAN will be 100. And we'll go ahead and say that the customer service VLAN will be 200. Okay, and then the next thing you need to do is, before you set up the VLANs and their names, you need to find out which interfaces are connected and make sure you got the right interfaces to assign to the VLAN here. An easy way to do that within Packet Tracer is to show the workspace list. Here you can just see exactly which devices are set up in your environment and what port they're assigned to. You expand the destination port here, and it even gives the name of the PC. So we can see sales 1 and 2 are connected to Ethernet ports 1 and 2, and the customer service guys are on 3 and 4. So that makes it easy. So what we need to do now is open up our switch, open up the command line interface. Go ahead and just say no to initial configuration. We're going to enable configure terminal here. Alright, now we're going to go ahead and just create our VLANs. So we said sales are going to be VLAN 100, so let's go ahead and do that. Alright, so we got that. Easy enough. If you ever forget what numbers you made your VLANs and what you named them, an easy way you can pull up that information within a Cisco switch is to just show VLAN brief. And here you can see your VLAN number with the name. Easy enough. As a good network administrator, we already got our documentation set up, so we don't even need to do that in this scenario. So let's go ahead and start assigning the ports to VLANs here. So we said 1 and 2 are the sales guys, so we're going to go ahead and configure those both at the same time. we're we're going to say the range of Ethernet ports 1 to 2. Go ahead and give them access to VLAN to VLAN 100. If I can type right here. Okay. And then we also need to do the same for the 3 and 4 interfaces, which are the customer service computers. Okay, so we got that set up. Our end devices are assigned to their respective VLANs. So let's go ahead now. As I mentioned earlier, devices on different VLANs are not able to communicate with each other, but guys within the same VLAN can. So let's go ahead and do that. We can see here Sales 2 has no functional ports. Yeah, what I think. We don't have DHCP set up here, so we're going to have to go in and set up some IP addressing here. So for now, go ahead and just hit DHCP. We're going to go ahead and that's going to change once we actually set up inter VLAN routing. But just for demonstration here, we're going to go ahead and make that DHCP for now on all of them. It'll give them a PIPA address. Okay. Alright, so we can see down here it was a successful ping from Sales 1 to Sales 2 because they are in the same VLAN. And we should see the same with customer service. Yep, successful. They were able to ping each other. But as I try to go from sales to customer service, we should see a failure. Yes. So since they're on separate broadcast domains, they're not going to be able to ping or communicate at all. The next thing we need to do is set up the switch virtual interfaces. It will enable inter VLAN routing, and they will, at that point, be able to communicate. So let's go ahead and get started with that. So we'll open our command line interface back up. And what we need to do at this point in the config terminal is enter the IP routing command. And then we're just going to specify, we're going to create the virtual interface now, the switch virtual interface for VLAN 100. And we'll give it an IP address. As well as its subnet mask all in one command. And then go ahead and do the same for VLAN 200 for customer service. Oops. Int VLAN 200. So as you can see, I gave it I kind of subnetted it a little bit. It went from 192.168.1.1 for the sales VLAN. We're going to go ahead for the customer service VLAN, give it an IP, give that virtual switch interface, 192.168.2.1 interface, or IP address. This is effectively, it is going to act as the default gateway for those separate broadcast domains, which will enable the routing between the two. So now, let's go ahead and see what happens when they try to ping each other. Oh, failed. You know what the problem is now? Since we enabled those switch virtual interfaces, we need to reconfigure our IP addressing on our clients to use that new default gateway, which are the virtual switch interfaces. So for now, we're going to go ahead and just set that statically. And as I mentioned, as a good network administrator, we should document all this. So I'm going to go ahead and just do that real quick with a quick text note. We set that as for the sales VLAN default gateway virtual switch interface. We set that to 192.168.1.1, and then for our customer service, we set that to 192.168.2.1. So that makes it a little bit easier just to know off the top of your head when you have good documentation, as a good network administrator should. Now let's go ahead and configure these guys. Just needs to be within that range there. Make sure to set the default gateway to what that virtual switch interface is. And do this for all the computers. Okay, so now we got all those set up. Let's go ahead and see what happens now when we try to ping across VLANs. Within the same VLAN, we still see successful here. Let's go ahead and clear that list. Alright, now let's go across. Now the first time it's going to say failed. That's normal within Packet Tracer. I think it's the same within the real world too, but it needs to go through the ARP. It needs to go through the ARP process, or the address resolution process. After you do that the first time, the devices should learn of each other's locations, and it should start to go through just fine. Yep, so now we see successful. Should be the same for on both sides. Yep, failed. Go through the ARP process. Yep, now we see successful. Let's go ahead and clear that. Oops. Now we can see that we can all ping each other just fine, and it's all a big happy world now. And we can kind of do the prettier process. The Packet Tracer has the simulation animation here, so let's go ahead and see that now. So we can see that the packets are making it through the multi-layer switch and hitting the virtual switch interface, and that's what's enabling the routing between VLANs. Alright guys, and this video shows a real basic understanding of how inter-VLAN routing really works. Here, yeah, as I said, this is a very simple example. In the real world, where other things are present, such as DHCP servers, other media servers and services, other WAN connections and such, there's going to be some additional configuration that's needed to make all of this continue working. However, for the demonstration purposes of this video, this works great. So I'm glad I got to share this with you guys. Let me know what you thought in the comments. Here in the future, I may add on to this project and show how this would work with DHCP servers, and just kind of keep going from there. And if you guys are new here, if you enjoyed, please consider smashing that like button and the subscribe button. I enjoy posting content like this regularly. I have plenty of other videos. It really helps me out a ton, guys. If you have any questions or want to see specific examples of things, feel free to leave that down in the comments, guys. I hope you learned something here, and thanks for stopping by, and until next time.